Let's take a look at some problem-solving application problems here and see if we can come up with some answers. The first question asks, Britt has $2.25 in nickels and dimes. If she has 40 coins in total, how many of each coin does she have? What we're going to do here is we're going to create a chart or a table for most of our problems and see if we can come up with their answers using guess and check method. All right, so I'm going to make a column for nickels and dimes and my total. And I'm just going to start out with 20 of each because we have 40 total. So if we have 20 nickels and 20 dimes, how much money do we have? Well, 20 nickels, that's $1, and 20 dimes is $2. So that gives us a total of $3, which is too much because we only want to have $2.25. So I'm going to kind of play around here, and I'm going to raise the amount of nickels and lower the amount of dimes to 30 and 10. So that would be $1.50 in nickels, $1 in dimes, and that would be 2.5. Again, a little bit too much still, so let's try 35 and 5. 35 nickels is $1.75, and 5 dimes is 50 cents. So when we add that together, we get $2.25, which is what we were looking for. So we should have 35 nickels and 5 dimes. Let's take a look at another problem. A pattern of squares is put together as shown. How many squares are in the 12th diagram? Well, in the first diagram, we have 1 square. In the second diagram, we have 3. In the third diagram, we have 5. And you can notice a pattern that it's increasing by 2 each time. So I'm just going to go ahead and continue this on. Try to write a little bit tinier so I can get all 12 trials in here. Almost get it in there. But we should get 23 squares are in the 12th diagram. A restaurant hosts children's birthday parties for a cost of $120 for the first 6 children, which includes the birthday child. So we can have the birthday child, which is Jaden, and 5 friends for that $120. It says each additional friend is $30. So if we're going to have 6 friends, that would bring us to 150 because 20 plus 30 is 50. If we have 7 friends, that brings us to 180. If we have 8 friends, that brings us to 210. But we're a bust there because we only have $200 to spend. So that means we can invite 7 friends. So Jaden can invite 7 friends to his party because it will cost his parents $180. Oswald is trying to cut down on drinking coffee. His goal is to cut down to 6 cups per week. If he starts with 24 cups in the first week, and in the second week he can cut down to 21, in the third week he can cut down to 18. How many weeks until he reaches his goal? Well, it looks like we're subtracting 3 each time, so the week 4 would be 15, week 5 would be 12, week 6 would be 9, and week 7 would be 6. So in week 7, he's down to his 6 cups of coffee a week. So it takes him 7 weeks to reach his goal. All right, Jessamine takes out a $150 loan from an agency that charges 12% of the original loan amount in interest per week. If she takes 5 weeks to pay off the loan, what is the total amount, the loan plus the interest, she will need to pay back? Well, in 1 week, she's going to have 150 and then that 12% interest. So 150 times 0.12 is 18. So she has $18 in interest per week, right? So in 1 week, she's got $18. And it takes her 5 weeks total to pay it off. And so that means she's going to have to pay $18 in interest the second week, $18 of interest the third, the fourth, and the fifth final week, because at the end of that fifth final week, she has her loan paid off. So 18 times 5 is 90. So she's going to have to pay her loan, which is $150, plus her $90 in interest. So altogether, Jessamine is going to have to pay $240. All right, I'm going to make two columns here for this problem. It says Grace starts biking at 12 miles per hour. 1 hour later, Dan starts biking at 15 miles per hour, following the same route. How long will it take him to catch up with Grace? So let's do Grace and a distance for her, and then Dan and a distance for him. All right, so in 1 hour, Grace can go 12 miles. In 2 hours, she's gone 24 miles. In 3 hours, she's gone 36, because we can see that pattern continuing. For Dan, in 1 hour, he's gone 15 miles. In 2 hours, he's gone 30 miles. And let's look at this already. So in 2 hours, he's already gone further than Grace has. So that means somewhere between hour 1 and hour 2, he has caught up with Grace, because notice that his distance is further than Grace's. So between 1 to 2 hours, he's caught up to her. Lemuel wants to enclose a rectangular plot of land with a fence. He has 24 feet of fencing. What is the largest possible area he could enclose with the fence? So a picture will help with this one. So let's draw that rectangular fence and our different options for the length, the width, and then the total area. So let's just assume that we start with the length of 1. And I don't want a cursive 1 there. I just do a 1. All right. If that was true and the lengths were 1, thinking of the total perimeter, that would have to be 11, right? Because 11 plus 11 is 22, 23, 24 for the whole perimeter. So the area is length times width, which is just 11 feet squared. Let's assume that this is now 2. That means that this would have to be 10. And my area now jumped up to 20. And this pattern continues. So what if the length is 3 and the width is 9? Or vice versa, depending on how you're looking at your rectangle there. We know that the area is 27. 4 and 8 is another possible combination. So 4 times 8 is 32. 5 times 7 is 35. And 6 times 6, which is actually a square. And a square is a type of rectangle. And that is the largest possible, because then we would start repeating the 7 and 5 and retracing our steps backwards, right? So 6 times 6 is the largest we can get. So 36 feet squared is the largest possible area that we can have with the enclosed fence. This next problem states that tickets to an event go on sale for $20 6 weeks before the event. So let's do one for weeks before. And then the price. All right, so 6 weeks before, the tickets only cost $20. Each week leading up, the price increased by $5. So 5 weeks before, it's $25. 4 weeks before, they jump up to $30. Then $35, then $40, and finally 1 week before, tickets cost $45 each. All right, the last problem we're going to look at today says in a one-on-one basketball game, Jane scored 1.5 times as many points as Russell. So I'm going to make a column for Russell and Jane. And we know that together they scored a total of 10 points. So we're looking for a total of 10. So I'm just going to start. If Russell scored 1 point, that means Jane scored 1.5. So that gives them 2.5 points total, which is not 10. So let's bump it up to 2. So if Russell scored 2, that means Jane would have had to score 3, because that's 1.5 times as many as Russell. And that means 5. Well, 5 is half of the total I'm looking for. So let's try to double that. If I do 4 and 6, that gives me the 10 total points. So Jane must have scored 6 points in the game.